Hello, Mr. Aaron, Mr. Ryan. Are you right?
Yeah.
Okay, good. Okay, so today's question, a simple problem. We're given apples, okay? And we're given boxes. We want to pack the apples in the boxes. So we were given apples or bananas. We want to put it in the boxes.
Why not pears?
Why
Okay.
not oranges?
Why not
Okay, that's fine. Pick a
strawberries?
favorite
Why not
fruit,
grapes?
please. Just pick a fruit.
Honeydew melon.
Come on, this is not important. Honey.
Honeydew melon.
Honey melon.
Honeydew melon.
I have no idea what it is.
HONEYDEW fingers well space.
Honey melon.
Honeydew melon.
Do. D-O.
DEW.
Yeah, this is the problem. You call some stuff like fruits and stuff. I don't know why, but then it might be because you're like, okay, we can see it better, but still, it creates more problems along the line.
That's right. Okay, so
Then why are you literally writing honeydew melon?
So we're given apples, just apples. We're given apples, and we're given boxes. So this number, so we're given 3 packs of apples. The first pack contains 1 apple. The second pack contains 3 apples.
If it's packs, then it's probably not. Or it's probably not like apples. It's probably something like cards.
Cards?
Yeah, it's probably something like cards.
What's cards?
You know cards?
Cards.
You know what a card is?
C-A-R-T, okay?
No.
No, C-A-R-D.
D. Do you know what a card is?
Okay.
Have you
card.
played cards?
Okay,
before?
card, okay.
Do you like Pokemon cards? You know, like those cards for like.
Okay, not important. Okay, so let's come back
No,
to
but you
this.
could packs and you said it's oranges. No, I mean apples.
We're given apples. 3 packs of apples. The first pack contains 1 apple. The second pack contains 3 apples. The third one contains 2 apples. And we're given 5 boxes. The number is the capacity. So for example, like the first box, we can put at most 4 apples in the first box. We can only put at most 3. So basically this is the number of the...
Why did you say packs before, but now you say box?
This is the boxes, the box, and we want to put the apples in, okay? So these are 1 pack, okay? Yeah, got it?
Why
So
do you
then-
say packs now and boxes?
Yeah.
For?
Yeah. No. Why packs?
If it's packs, then why boxes?
Say, say just like groups or bags.
Groups of bags.
Just say groups. You didn't even describe the whole problem yet.
Okay, so let me describe, and then please, and you can describe it after me to present a better way, okay? Okay, so let me get this, okay? We given apples. The apples are packed in separate, packs, okay? And we given the boxes. 5 boxes. The numbers represent the maximum capacity that each box can be put the apples, alright? For example, like 4 means that the first box, we can only put maximum 4 apples in it. 2 means the last box, we can only put 2 maximum apples in it. The question is that we want to find out the minimum number of boxes that we can put all the apples in it. If we can't do so, we return -1. So for example, the first one, what's the answer? They are 1 apple plus 3 apple plus 2 apple. They are 6 apples altogether. And we want to put it in the boxes. So which boxes we should select to put the apples?
3, 1, 2.
We can put these apples separately. For example, there are 3 apples here. It doesn't have to go into the same box. Okay?
I thought you said they were packs.
Yeah, we can unpack it. Good point. Okay, so that's my bad. Okay, so these apples are packed, but we can unpack it. We want to redistribute the apples into the boxes. So these apples belongs to the same pack can go into different boxes. Okay, so for example, like 2 apples here. It doesn't have to go to this box. 1 apple can go to here, 1 apple can go to there. Okay, so what's your solution? What's your strategy of picking the boxes to put the apples?
So you add 1, 3, and 2, which is 6.
Yes. Okay, we have 6 apples, and which boxes we need to choose?
Like
The minimum number of boxes.
678.
2. Why is it 2?
Because if you take the largest two,
Four,
then that's
5.
9.
Yeah, okay,
And
so
9 is larger than.
okay, so how about the second one? 555. There are 15 apples. And
You take all of them.
all of them. Well done. Okay, so one question. Does the order of apples matter here? Or the numbers, the range? No, right? Why is that?
What's the point?
What's the point? A good question. So what's your strategy of
What's the
solving this?
point?
What's your strategy of solving this?
Just add them all together.
Add apples all together, and then I give you the number of apples for each pack, and then you add all the numbers. And what to do next?
You just pick like the largest number. If the largest number from B is smaller than A, and then you pick the two largest numbers, and you keep on doing that until B is equal larger than A.
Okay, so yeah, so we sum all the apples, and then we want to put them in the boxes with the largest capacity first, right? And then we basically sort the boxes in non-ascending order. Okay, so from biggest to the smallest, right? For example, like 5, 4, 3, 2, 1, right? So we choose the box with the 5 capacity first. And then after that, we move to the 4, move to the 3, move to the 2 and 1. Okay? Yeah, that's the strategy. That's the greedy. That's actually a knapsack problem. One classic way of knapsack. You know knapsack, right? You have a knapsack. You have a few items. These items has value, and you want to pack your knapsack at the same time to achieve the maximum value. But here, this is much simpler. We want
What's
to
a knapsack?
the bag. Okay, it's basically bag, right? Bag. Okay, so here this is much simpler. So we want to minimize the number of
that
boxes
even a
knapsack.
word?
Okay, sorry.
Is knapsack even a word?
Yeah, it's a word. Yeah, it's a word.
Are you sure?
Yes, I'm sure about that
I
because
don't
there's
think
a
so.
there's a you can Google it. Okay, you can look it up in the dictionary. There's a famous math optimization problem which is called knapsack. We talk about that, right? We given a few items, and
Oh.
different items has the weight, and then has a value, right? And we want to put it in a knapsack, okay? As long as all the weights we select is smaller than the threshold, and then we want to maximize the value, okay? Yeah, something like that, okay? So coming back to this question, so it's simple. We just want
Can I
to.
get the dictionary?
Yeah, okay. So in this question, it's simple. We just want to sort the bags. We want to sort the bags in non-ascending order, okay? Yeah? We want to sort the numbers.
You mean descending?
Yeah, the non-ascending is basically descending from the largest to the smallest.
Descending.
And then we want to
That's
try,
That's descending.
okay, we want to try the
That's not ascending. Not.
non-ascending, okay?
That's not even a word.
That's not
And
important.
non-ascending can be like 1, 2, 3, 4, 6.
Oh, is
1,
this
2, 3, 4, 6, 5.
Is this a bag carried on the back by soldiers, hikers,
Okay.
etc.?
Okay, so let's look at this. Okay, so the idea, as you agree, right? We sum up all the apples, right? Actually, the order of the apples does not matter. No matter how we arrange the apples in different packs, it doesn't matter as long as we can put all the apples, right? So the most important thing here is the number of the apples, right? So we want to put the apples in the boxes. So our strategy is to greedily put the apple to the boxes with the larger capacity.
Yeah, I
okay.
thought it was like rucksack instead of knapsack.
Okay. So let's try the code.
Rucksack
Okay.
is like an ordinary bag.
Yeah. Define pack
By the
apples.
way, rucksack is like an ordinary bag, but
Apples and boxes, right?
never mind.
Then the total number of apples, which is the sum of apples, right? Okay, the sum of all apples. If the apples is bigger than the sum of the boxes, the capacity, then we return -1, right? Because there's no point to continue, right? All the apples, the total number of apples is bigger than the total capacity of all the boxes, we return -1. and then we need to sort the boxes, right? B.sort. But this is sorting the B boxes in ascending order. In computer, right? If you don't specify anything by default, you call the sort function to the array. It's sorting in ascending order, meaning that the boxes will be like 1, 2, 3, 4, 5. But we want it to be reverse, right? So we put a parameter called reverse equals true, meaning that we sort the B in the descending order. We put this I index equals 0, and then Y we still have apple. YA bigger than 0 or YA simply. Okay, then we have to check. If it's bigger than the current box's capacity, we still have apples, and we check if the number of apples is more than the capacity of current box. So what should we do now? So look, I have 10 apples and the current box is
Do
5.
it again.
Do it again. Yes, do it again. So but do it again then. Okay, not important. So how do we do it again? For example, this is 5. This is 4, this is 3. Also, we have 7 apples. 7 is bigger than a 5. So, we need to subtract 5 from 7, right? So, the remaining is 2 apples. 2 apples, but now we need to move to the next, right? So, A minus equals BI, because we need to update the apples number, right? We have 7 apples, and the 7 apples is bigger than the box with 5 capacity. So, what do? We put a 5 apples in here, right? What's remaining? 7 minus 5, right? 7 minus 5, 2 apples. And then we need to move to the next box, plus equal 1, right? Now, look, 2 apples is smaller than 4. So what should we do? We don't need to continue, right? We just break. Am I right? Right? Because look, I have only 2 apples left. I can put all the apples in the second box. So there's no point to continue. So we just simply break this.
Yeah.
And then the answer is return I plus 1, right? Because I start from the 0. So once we are here, 1. So we need the 2 boxes, 5 and 4. Can you explain to me what's A minus equals BI?
Take away the largest number.
Take away the current box from the apples, yes?
Yeah.
Okay, good. Okay, what's the time complexity?
Oh, and log n.
Oh, and log n. Yeah, we need to analyze one by one, okay? Sum A. Let's say this is n. The number of apples is n. The number of boxes is m, okay? So sum
Yeah, that's
A.
why you don't buy on M.
So sum A, this is linear, ON, right? Because we need to accumulate all the numbers, all the apples in A. Basically, we added up all the numbers in the apple array, ON, right? Sum B, here, this is OM, okay? B dot sort, sorting, right? ON log n, but here is M, so it's OM log M, okay? Okay, YA, this is tricky, right? We are taking the numbers from A. And in the worst case, all the numbers will be taken. So that all the numbers will be taken. This is all the numbers will be deducted from A. Then all the numbers in B, right, will be iterated. So this is, in the worst case, is OM. Okay?
M.
So what's the time complexity? ON plus M plus M plus M log n.
O-M.
So what's this?
O-M. Log M. O-M.
M plus another M, right? So OM plus 2M plus M times log M. So what's this?
O-M log N.
Why?
Because it's trivia.
These two terms compared to that is smaller,
Are you
right?
sure it's called trivia?
Actually, okay, we are not sure about A.
Actually.
Yeah, because look, this one is smaller compared to that, but we're not sure about N, right? So it's better to write OM plus M log M, right? Because we don't know how many apples and how many boxes. The A, we could have 1,000,000 apples and only have like 10 boxes, right?
10 big boxes.
Yeah, adding numbers. I'm talking about N. You're saying how if there's like 1,000,000.
Okay, this is ON, right? The
No,
constant.
I'm not talking about like the
This
whole
is
thing.
O1. Okay,
I'm
ON
not
is like
talking
that.
about I'm not talking about the whole thing.
Okay.
I'm just saying.
Adding up the million number.
Yeah. Before you're talking about if N was 1,000,000 and M was only 10 boxes.
Yeah, but each box could have like 1,000,000 capacity, so you never know, right?
Yeah, but if it has to be like million, adding million numbers because you have to add million numbers together.
That's right, yeah, because I have to know the total number of
Then
apples.
why were you Why
Okay.
were you talking about a million numbers if it's pretty much the same thing as other examples?
No, that's because the complexity is n plus om log m. So can we drop this? We don't know how big is which one is bigger, right? N and m times log m. The m could be very small. N could be a million. In this case, n is much bigger than that, so we can't drop it. Okay? Does it make sense now? Like n there could be a million apples, but 10 boxes. So of course this is bigger than that, so we can't drop it. Okay? Why we can, in what case we can drop it?
Yeah, but if it's a number.
It is a number. Yeah, it's a number. We are talking about the complexity. We want to find out which term dominates. Okay, when we say O m plus m, okay, so which one is smaller? We don't know, right? Here, but we know it's O m plus m times log m. This is smaller because look, both terms are m, right? This is
M.
this
not
is
M.
linear. But this one is linear times a log, so it's usually bigger. Okay? Does it make sense now? Okay, m. Okay, does it make sense?
M.
Yeah. Okay. So today we talk about this problem. Next lesson, I was going to talk about the second solution, but we're running out of time here. So next lesson we're still talking about this. But instead of doing a while loop, we can use the binary search, bisect left, okay, to find out the total number of boxes we need, okay? And we're going to talk about that. Remember here, this is OM, right? So in the next lesson, we're going to talk about using the binary search to bring down the complexity from OM to O log M, okay? Yeah, make sense? Okay, that's it for today. Bye-bye. Bye.